started. This one is calculator active. Anytime I see calculator active, I also think Desmos. Okay, so number one, there is a mistake. Thank you, Sean, for telling me about it. Number one is supposed to be y equals negative 9x plus 5. Sorry about that. Y equals negative 9x plus 5 is what that one should be. So you have a system of equations shown below. Y equals negative 9x plus 5 and y equals 2x squared, which is an x value of the solution to the system. Okay? You have two different things. What should you do with them? Plug them in what? What is the easiest way to do this one? Desmos. All right? The easiest way to do it is to put it in Desmos. So if I put it into Desmos, negative 9x plus 5, negative 9x plus 5, and then what's the other one? 2x squared, okay? When I put them into Desmos, I'm trying to find what? Where they intersect. So I click right there. And, all right, that's one of the answers. They also intersect up here, okay, if I click there. So what's the answer that's on the multiple choice? Negative 5. Okay, the answer is A, okay? Number 2, Joseph and Brett are standing on the roof of their houses. Both threw a ball into the air. What else does it say? The height of the ball, x seconds after Joseph threw it, is represented by the function negative 16x squared plus 24x plus 5. The height of the ball, t seconds after Brett threw it, is represented by the graph below. Okay? Which statements comparing the pass of the balls is correct? So, I have a picture, I have a graph of Brett's, okay? This one right here is whose? Joseph. What would be helpful to have about Joseph's? A graph. How can I get a graph of that?
Desmos.
Okay, and then in Desmos you put it in your phone if you want to grab a Chromebook, but do it quickly. So we're going to put that in Desmos. That way we have a graph of it. Negative 16 x squared plus 24x. Are you sure? No, it's not. Hold it open. Okay. Remember that in Desmos, if you hit the house, it'll go back to the standard looking screen. Okay? All right. Let's read answer choice A. The height from which Joseph threw the ball is 2 feet greater than the height from which Brett threw the ball. Okay? Remember, Joseph is the one that we have in Desmos. So if I pull Desmos up, where did Joseph throw the ball from? Very good. You have to click here. You can't click here. This will give you a negative answer. Can you throw the ball from a negative place?
No.
No. So you have to start where it's positive. So if you click right here, it starts being positive at 5. So Joseph threw it at 5 feet. Okay? Now let's go back and look at the paper. Where did Brett throw the ball from? 8. Okay? Is there a 2 foot difference?
Yes.
Nope. 5 and 8 there is 3. Okay? So it's not A. B, the ball that Joseph threw, again, remember Joseph's in Desmos, he threw, it was in the air for 0.25 seconds longer than the time that Brett threw it. Okay, let's look at Desmos again. How do I find out how long this was in the air for? He starts right here, he's throwing it. Is it in the air? Is it still 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 in the air? Right there is how long long it's in the air for. Okay, so click right there. How long was Joseph in the air for? 1.6. Okay, 1.685. What about Brett? How long was he in the air for? Maybe 1.4? Was that 0.25 difference? It's close, isn't it? It's pretty close. Let's star that one. That one might be the right answer. Okay? The ball that Joseph threw was in the air approximately 0.32 seconds more than the time. Sorry. Actually, I don't like this question. Let me read D. The ball that Joseph threw went 15 feet above the roof of his house as compared to the ball that Brett threw, which went 12 feet above the roof of his house. Okay. Do they even tell you where the roof is?
One of the movies, they said that they're standing on the roof.
Oh, thank you, thank you. Okay, so they're standing on the roof. So if he's at 8, that must be the roof. How high did his go? So how high above the roof did it go? That one went 4 feet above the roof. Okay, so does D work? No, D is absolutely not correct. Okay. Okay, I don't like this question. I think it's too technical, but let's just go ahead and pick the best answer. If this is 1 and this is 1.5, what's in between them? 1.25. Okay. And then, does this look exactly halfway or not?
That looks halfway.
Okay, what's halfway between 1.25 and 1.5? 1.375. Okay, so we're saying this number right there is 1.375. Desmos already gives it to you. What's the number right here? 1.685. Subtract those. 1.685 minus 1.375. What do you get? What do you get when you subtract 1.685 and 1.375? What? 0.31. So what is the best answer? C. 0.32 is closest to 0.31. Okay. Real quick, how can you find the number between 1 and 1.5 with your calculator? How can I find the number that's in between them with my calculator? What could you do? You add them and divide by 2. Then I take these two numbers and I add them and divide by 2. Will it give me that one? Yes. Okay, so you have a calculator for this. This is calculator active. Okay? All right. Number 3, Shelley compared the maximum value of the function f of x to the maximum function g of x shown below. Okay? All right. How do I find the maximum of this one? Desmos, thank you. So I have to put it in Desmos to find the maximum. So please type that in. Negative 2x squared plus 8x plus what? 2? Okay. The maximum is the highest point. You click it. Do you want the x value or the y value? The y. So the maximum is 10. The maximum for this one is 10. We did that in Desmos. Okay. What's the maximum of this one? 9. Okay. And the question says, what is the value of the larger maximum? What's larger, 10 or 9? 10. So the answer is D. Okay. All right. What is the largest integer value of x such that the value of f of x exceeds the value of g of x? Okay. What can I do with this one? What? Okay, we can try Desmos because normally that's the easiest, so it's worth giving it a try. So x squared minus 6x plus 40. And what's the other one? 1.5 to the power. All right, I'm gonna zoom. Oops, wrong way. Where's the green one? All right, there it is. Okay. All right. What does it mean to exceed? To surpass, to be bigger than that? At what point will one start being bigger than the other? Where's the place to look first? So if I want one to be bigger than the other, when is that going to start happening? When they do what? When they cross. That's when it's going to start happening. So if I click where they cross, looks like right there, 8.391. After the point that they cross, does the other one start getting bigger than the other one? Yes. Okay, so 8.391. The thing to remember is that it asks for an integer. Does anybody know what that means? It's got to be a whole number. So the answer is not 8.391. It's not even 8. Oh, wait. Let's see. It might, hold on. If we go back to, if I go back to 8, which one's bigger, the green one or the purple one?
The green.
I don't know.
Green's bigger.
Okay, so let me ask you this. Starting at this point, which one gets bigger? The purple one is getting bigger faster. So if I go below this, which one is bigger?
Green.
The green one. So it has to be past. It can't be 8.3. It has to be even bigger than that. 9. Okay? And that was a horrible explanation. I'm sorry. So the answer is 8.3, but it has to be an integer. So let me see if I can explain this a little better. Has to be an integer. If you go backwards to 8, which is how it rounds to, it won't have exceeded it yet. So you've got to go to the next whole number for when it will have started to exceed it. So the answer is 9. Okay? All right, number 5. Jenna compared the minimum of the function x squared plus 2x plus 4 to the function graph below. What is the difference between the minimum values of the two functions? Okay, so what do I need to know about this one? The minimum. How do I find the minimum? I put it in Desmos. All right, so if we type it in, x squared plus 2x plus 4. What is the minimum? What is it? 3. Okay, so the minimum of this one is 3. Look on your graph over here. What is the minimum of this one? 0. So what is this point? Somebody call out that point. What are its coordinates? -1, 0. And you always want the y value. Okay, you want the y value. So we're taking the 0. Okay, we're taking the 0. And what does difference mean to do? Subtract. 3 minus 0 is 3. Okay, so the answer is B. All right. Austin and Jana threw grappling hooks into the air. And just y'all's, did it get cut off too? All right, what number is this? Number 6? All right, number 6, let's fix this. All right, let's write that down. The function should be f of x equals negative 16x squared plus 32x plus 5. Yep. Here it is. Negative 16x squared plus 32x plus 5. And this is Austin's. Okay, that represents Austin's. Negative 16x squared plus 32x plus 5. Okay. What is the graph showing you? Jandas, okay? The graph is showing you Jandas, okay? Huh? All right, so that one's Jandas. What do I need to know about Austin's? What do I need to know?
It's negative. It's a negative.
Salting. It starts at 5.
Okay, those are all good answers, but if I'm going to answer this question to the best of my abilities. What?
How many seconds?
Put it in Desmos.
Grappling hook.
Thank you. I need to put it in Desmos so that I can see a whole picture of it. So that way I have all the information. Negative 16x squared plus 32x plus 5. Okay, see you after lunch.